right click on the screen, go into properties and material properties. Okay, now we could add, press add, and here we are in steel based on the ASTM standard, and defining A36 and say okay. We have another one based on the ASTM, and it's gonna be A572 grade 15. Okay. Next step is to define section. So as you can see in the top here, beside the material, we have section button. We just press it, and by pressing add, I can add new material. So for the first material, I'm going to define the main girder material, a section actually. Call it main girder. Main girder, I want the box, and going with the user define, and the values I'm entering here, 2100, 600. Actually, let me switch the units first. I'm switching to kilonewton and millimeter now. Going to do that. Right, for the user first, main girder, H2100. Let me select the box, 2100, 600, 10, and 10. So you can see the cross section here. Pressing OK, and defining another section for the crossbeam. So name is gonna be Crossbeam, and I'm selecting an I section by the user define, and entering the values here, 1540, 500, 14, and 27. You can actually select from the library. You can select different type of I sections, but here I'm willing to use the user defined section. Okay, say okay. We have 6 sections actually. So for saving the time, I'm opening a new file which already have the sections defined. So if we come here, we can see to the left side. On the left side, you can see the materials and the sections. So what I'm going to do, Control select all and delete this. Okay. Alright, so now I'm going to model the arch, and for doing that I'm going to use one of the wizards which is going to model, structural wizard, and arch. So you can see that we could have different type of arches. So now I'm going with the default, and here number of the segments I keep it to 10, and boundary condition we could have pinned. You can see it down here in this window. It could be pinned, it could be fixed, or we could say none, because I'm going to define the boundary condition later. Alright, so this span width gonna be 50, height 10 meter, and the material for the arch rib I'm going to use A572, and for the section we have here arch rib. Okay, by pressing OK, we have the arch rib here, and if I in the top view here we have a icon. So if you press it, you can see the 3D or extruded view. I'm gonna turn it up for now. What I'm going to do next step is to define the model these hangers. So for that one, I'm selecting the nodes by top here. I'm selecting this one. Select element by window. I have all the nodes which I'm going to add the hanger to, and then if I right click here and go to element, there is an option extrude, which what I'm going to do is to extrude nodes and create line element. As you can see here, node to line element. So I'm changing the material to 572, and the section gonna be hanger. Alright, and then I'm going to project it in respect to one line. So to define this line, we need 2 points. This is point 1 right here, and this point 2 right here. So if I press apply here, I'm gonna have the hangers. So now quickly I'm going to add the main girder. So I can close this and go to the element, create element. Again, material and main girder. Okay, I stick with this. And main girder gonna be, you have to ensure that you're checking these two node and elements, which help us if I create this one long element. The software automatically divides the element to whenever it's intersecting to any node or other elements. So here, if I use the shrink view, you can see that they are like separate elements. Okay. So the next step is, if you go to the 3D view, we have one side of the arch. So I'm going to model another part of the arch. So by pressing this button here, I can select all, and then right click, element, and translate right here. The bridge width is 14 meter. So I'm saying that here I gotta say 0, 14, and 0. I'm going to translate everything, and then pressing apply, and I have both sides of my arch. So the next step is to create crossbeams. So for creating crossbeams, I can again select the by pressing the Control and your wheel button mouse, you can just easily, freely now rotate it anywhere you want. So I'm coming to here and selecting element by window. I'm selecting these elements, and then switching back to here. Again, right click, element, and extrude. Again, we're gonna extrude nodes and create line elements. We could say go to the projection, and then from the, we're gonna extrude this point in respect to this line. Start from this point and end at this point. Okay, say apply, and we have all the crossbeams. Now I'm trying to model the braces. So let me switch to top view. Now I have my crossbeams and main girder, and I need to add the stringer in the middle of these crossbeams. Therefore, I'm just right click, going to elements, create element, and there is one more option here on the right bottom side of the screen. You can see here. You can see here number 2, which gives me an option to divide each element to certain number of the elements, or actually not dividing that, but give me like a center point or like a point at the 1/3 of the length or something. So let's say if we have 2, so I have a node at the center. So if I change it to 3, so I have at the 1/3, 2/3, and at the end. So this option is helping me for modeling. Now I'm going to, because I'm going to have this stringer in the center, I'm going to put it on 2. And then from this point to this point. And because I selected node and elements, now it's just divided by the 10 elements. All right. So now I'm going to create these braces. So what I'm going to do, let me close this and right-click, Elements, Create Element. I'm selecting this material, A36, and then going here to the bracing and stringers. Okay. And then click here, click here. This is one element. Again, click here, click here. We have another one. So instead of doing for all the model, like now doing it by hand, I can use another option which called copying or projecting. So what I'm trying to do here, first selecting this element. By here, we can select a single element, like this and this. Then right-click on an element. We could go to Translate, and then define what distance are we going to do here. You see when I'm clicking on that, it becomes green. So I say from this point to this point. Let me select it again, from here to here. Okay. So what else I need to do? I need to multiply it 4 times, copy it 4 times, and say press apply. You see we have it all. So what I'm going to do, we have the same braces on the other side of the arch. So I'm going to use the mirror, which is going to make it very easy. So I'm selecting previous and this one. Yes. So I'm selected this one and right click, going to elements and this icon here, mirror. Okay. By pressing mirror, we're going to be on the YZ plane, and you see it's green again. So I want to say in respect to this point and press OK. So I have it all here. So let me show you the extruded model, and going back to the wire. Alright, I have to do the same thing for the top of the arch, but for time saving, I'm gonna open another file, which here we have modeled everything. Okay, now I want to do 2 things. One is defining I'm going to define a group for you. So is it going to sections, crossbeams, you can see them here, and then going back to group, on the structure group right here, right click and say new. So I'm gonna have crossbeams. Okay, and then easily drag and drop it here. You see that 22 elements are added to this group. Okay, going back to work. Next thing I'm going to show you is how to add the boundary conditions. Alright, so simply right click, go into boundaries and support, and now by here selecting a single element, So I'm selecting this node, and I want all the dx, dy, and dz be restrained. So say apply. You can see here. On the next element, I want just dx and dz be restrained. Okay. Next node here, just dy and dz. Apply. And the last one, just dz. Okay. Say apply, and we have the boundary condition here. So one more thing we have to do is to apply the end release on some of the elements, on hangers, braces, and crossbeams. So what I'm going to do now, select the hangers and end release them. So we could go to, let me close this, go into sections, hangers, double click on them, and they are selected. Now we can go to right click on the screen, boundaries, and you see the beam and release. Okay, press that. For the hangers, I'm going to release MZ for both ends. So just simply select these two. You have other options, pin fixed, or other options, and then say just apply, and you can see this small green circles on the both end of the hangers. So we have to do the same thing for braces and crossbeam, but for time saving, I'm going to open another file. Okay. Up to now, I modeled staff geometry with SI unit. Now I'm going to apply loads, and then I'm at the right bottom side here. You can switch your units anytime you want. Then the software automatically take care of whatever you modeled. So there's no confliction here. So I'm selecting kips and foot. And we start. Alright, here also supports and beam end release, which can now I can display it for you. You can see all the elements are applied. See on display. Alright. So here is a 3D view, and I'm going to define the load. Alright, once I'm modeling static load, and also later on I'm defining the moving load. So for the static load, right click on the screen, go to the load and static load right here. Okay. We call it, okay, the name could be dead load. And the type is a dead load. Alright, add. We have another static load. We could call it sidewalk. It's also dead load. The type is dead load. Add. Alright, close. Now we have to apply these static loads on the main girders. So I'm going back to section and selecting the main girder. You can see they become red. What I can do, right click, go into load, and element beam loads. That's a distributed load. And here I can select what I want. I want the dead load first, and then we don't have eccentricity. I'm taking it off. And the value is going to be 0 and 1 because the relative 0 means the beginning and 1 means the end. And the value going to be negative 6.2 kip per foot. Alright, apply. You can see it here. I want to add another thing also, sidewalk. Let me close this. Select main girder again. Load and element beam load here. The same thing with the sidewalk. Relative here, we don't have eccentricity. And the value for the sidewalk, I'm putting 0.5. Okay. Apply. So close. Now here we have two loads. I can display them. You can see the values. Also for this one, display. You can see the values. Okay. Now we're done with the static load. We're going to define the moving load. So right click, load, and moving load analysis down here. So first thing is we have to define the moving load code. So we're going with H2 LRFD. Say OK. Now we have moving load based on that. Again, right click, going to load, moving load, and we have to define traffic line lane. Okay. Right click on that, and okay, let me just simply display undisplay the loads here. Okay, so you can see the clear picture. All right, coming back to the traffic line lane, we have to add lane. I call it lane 1. Eccentricity with negative 11.5 feet, and the wheel spacing 6. I'm going to apply it to the crossbeams. So this is the group that we have defined there. We could have the skews at the beginning or end, but for now we're going to just put 0. And then we have to assign these to some points. We're selecting 2 points to define a line. So the one which is green now, showing me the point that I have to select for the first point. Going to be here, and the next one which is green now, showing me the last one. So by clicking this, my first lane is defined. Okay, you can see it here on the green line showing the first lane. I have to add another lane, so lane 2. The same thing with different eccentricity, negative 34.5, wheel spacing 6, again on crossbeam, and applying to the same line, because this eccentricity is respect to the line which I'm selecting now. By pressing OK, we are seeing that we have 2 lanes defined here. If I move to the top view, we can easily see them. Okay. Next step is to going to load, moving load, static load. Okay. Defining the vehicles. Alright. Add a standard vehicle. So you could have like a user-defined vehicles also, but for now we are just going with the standard vehicle. So we're going to define 2 vehicles. One is HL93 truck. Say OK, and we are applying 33% for dynamic load allowance. So OK. Add another vehicle, HL93 tandem with 33% again. OK, and we defined our vehicles. All right, close. Next thing is to define the moving load cases. So going to load, moving load analysis, and moving load cases. Alright, simply press add load cases. I call it moving load, MVL, okay. And then add okay. Now I'm going to define 2 combination, one for the tandem for the both lanes, and the scale factor I remain with 1, and the minimum number of the loaded lanes I'm defining 1, and maximum 2 because we have 2 lanes. Okay, so I'm adding another one for truck. the same thing, scale factor 1, and minimum number of loaded lanes 1, maximum 2, and apply for both of the lanes, add it, and say OK. Now we say pressing OK, and it's done. The very last thing we have to do before we run the analysis is to define the analysis control. So we're going to analysis, moving load, analysis control. But we have something here, analysis method, influence line or all point. We're going with the influence line, and the number of elements we're increasing it to 5. Let me switch to all points here. Alright. And on the frame, we're going with the normal and concurrent forces. And press
muted.
here,
Muted.
so here when you're selecting on this bottom, normal and concurrent forces, it gives you the option which later on you can see the all loads together for each element. For example, if you want the maximum moment, you see the maximum moment on one element, you can see the axial load and shear forces on that element for the moving load. Alright, I will show you later. Pressing OK, and we are ready to run the analysis. So let me open other file and perform the analysis. Alright, just by clicking this button at the top here. So probably takes a couple seconds to finalize it. Alright, here in the bottom there's a message window which you can see while it's running, or it's a kind of box for communicating with the user, I mean machine coding communicating with the user. Here you can see 5.51 seconds to finish the analysis. Alright, now let's check the analysis, see if the analysis are correct. So quickly I'm going to check the reactions. So right click on the screen, go to the reactions, reaction force and members. Okay, what I want, I'm just checking simply for the dead load first, and then for FZ right here, let's say value and legend. Okay, say apply. By clicking, so I have the value for the dead load here for the supports, and then by clicking on here you could have the values on a tabular form. So what I want here, this is a dead load, okay, and I have the results here. So if because we entered our loads by kilonewton, so if I switch it to kilonewton, you can see that we had this load total value for the supports is equal to the actual dead load that we applied. Alright, so it seems correct. One more thing I'm going to check, let me close this, is the deformation. So going to the deformation, displace contour, and let's say for dead load here, selecting dead load, deform shape, and apply. Alright, so if okay, let me show you the deform shape. Apply, and I'm switching the top here, I'm switching to the 3D view. So you can see here that the deflection is seems reasonable, and also values here you can check them on this contour at the right, changes from 0 to this value here. So it seems that the results are reasonable, so I'm switching to actually defining the load combinations. Okay. So for defining the load combination, we're going to, at the top ribbon, we go to the results, combinations. Say we have to define a name for that. So that load combination 1. And here on the right side, we could define the loads with their factors. So first I'm defining the dead load. Let's say factor 1.05. For sidewalk, the same factor, 1.05. And for the moving load, going with 1. This is the way to enter the load combination manually. You have also another option here, down here, which is called auto generation. So by pressing that one, you can actually, let me go to H2LRFD, and by clicking this, the software automatically generates all the load combination required for the code. So we'll go with the still H2LRFD and just press OK. You could see we have all type of load combination for strand and service. Okay. I'm closing this. Another thing I'm going to show you now is to check to see the visual moments and stresses. So I'm right click on the screen, go to the force and beam force beam diagrams. Okay, let's say for selecting for the V maximum, moving load maximum, and I want moment on the MY. Alright, solid fill, contour deformed. I don't want a deformed shape, I want just a contour, and say apply. So you can see that a bending moment and each element is shown here. What you can do, you can show them in the tabular form by pressing this button here in the top left and then selecting what do you want. For example, here I want to select moving load maximum. Okay, pressing OK, and I have entire the elements and the moving loads. Let me switch this to the keep fit. Okay, and what you can see here for axial load, shear, and moment, these are actually envelope result. So it doesn't mean that for each element, for example, for the first element, when the moment is 20 cube foot, is exactly axial force at that point is 0. So these are like envelope. So if you want to sort them for example, maximum moment, just simply right click on that and say view by maximum value item, selecting the one that you want. For example, I want the moment Y, say OK, and now the software is creating another table for me which is sorted for the maximum moment. For example, here if we have the moment Y for this value, the shear, torsion, axial loads are given for that element at that point. Okay. Another cool option that the software has is called moving load tracer. Moving load tracer actually is giving you the load pattern which has caused the, for example, maximum moment at a certain element. Let's see how it works. By right click on the screen, coming down to the moving load tracer, and for the reaction force and moment, or let me go to the beam force moment. Okay, here we could select whatever I want. I want the maximum moving load, and then element. See here, if I click on that, it becomes green, and I can select the element. Let's say I want this element right here. So it automatically writes the number of the element, and then I want my, and then say apply. Let me see. Okay, so take this off, and for this element right here, apply. Okay, you can see it here. Let me switch this off. Then you can see the wire view, and if I move to the top view, you can see for certain element, this is the moving load which causes the maximum moment. Alright, so if I change that, let's say I want to know for this element, apply, and this is gonna be another load pattern. So one thing that you can do is by pressing this button here, you can actually save this load as a static load, which you may apply to your structure as a static load, and you don't need to run the moving analysis anymore. So pressing this button, and it asks me to name, say OK. So it automatically save it as a text file, which I can open it later on in the software, closing this, and then going to Tools, Command Shell. Okay. Now here in the command shell, you can just insert actually saved text files and apply it to the actual model. So what I'm going to do, open this one. Let's say this one. Say OK, and then run. Yes, overriding. And you can see that in the load cases, we had 2 load cases, and now we have 1 extra. So I can just display that, and this one is so probably I opened a different file, but it just applies a static load on the structure, which when your bridge is like be larger than what we model today, so it probably is a useful option. Alright, so we are done with the arch bridge, and I quickly want to switch to another beam. So if you have any question, please type it, or you can email us. My colleague Aaron is here and can help you. So let me open a new project. No. What I'm going to model now is a reinforced concrete slab. So it's very easy and quick. I'm going to show you how effectively could the software model this reinforced concrete slab. So for this one, I'm just directly going to model and structural wizard, and down here, reinforced concrete slab bridge. Okay, pressing that one, and we have this window open. So we have to actually fill up this dialog box. So first we have to define material. Right click on that, material, add. We're going with the concrete ASTM standard, and let's say we're going with the grade 5000. Okay, I'm done with this, close. Then on this point here, you can define the spans. So you could have equal spans or different size spans. So here I'm sticking with the default now. We have 44, 56, and 44 feet spans. Okay. And also you can here define, there is a bottom here radius. You can define curve for the for your structure, but for now I'm not going to use that. And also you have an option skew. You can define skew for beginning and end of the breach. Here you can enter the geometry of the breach. Here is the thickness of the breach, T. This T1 is the thickness of the integral abutment. So this, let me change it to 0.3, and A1 gonna be 1.6, and A2 is right here. So you need just to follow this picture at the top and just simply enter the number that you're willing to have. What's going on? All right, excuse us. So, something happened here. All right, sorry for that. There's some noises here. All right, so and down here on the boundary, we could define supports or elastic links. So if I define elastic links, I have the freedom to define stiffness in 3 directions, X, Y, and Z for abutment and piers. So I'm keeping them as they are, but you can simply define them. And also, we want to have one of the supports as fixed. So I'm selecting pier 1 as a fixed support, and now we are done with the longitudinal direction, and I'm moving to transverse in the top. Okay, so we had longitudinal, we're done with that. We're moving to transverse direction. All right, for the transverse direction, actually, for we could have 3 types. So we stick with the type 2, which is different on the barrier, on the sidewalk, on the carriage length, and in the median. All right. So the same thing here. By following this picture at the top here, you can enter your values. For example, this B1 gonna be overhang is the left side, and this B2 is defined as the distance between these bearings. So I'm sticking with the default values. N is the number of actually spans. So, and when N is 4, we're gonna have 5 bearings, and the transfer directions we're gonna fix one of them. So I'm going to fix the bearing number 3. We're done with the transfers. Now I'm switching to loads. Okay, so now I'm going to select the HLRFT and then defining the moving load code. Just press that, and you have another dialog box coming here. Select H2LRFD and say OK. And if I move to, OK. And then we have self-weight, we have payment with the different thickness and weight, which you can easily change them based on your inputs. And barrier, and a median, and sidewalk. I'm going to select sidewalk also. Also, you can define live load as predefined here for HL93 truck, which you can later on modify them. We have option here for settlement and temperature, but for now I'm going to take them off and we're going to use them and just say OK. Before saying OK, you can also save your model that you created, and just open it later for if you want to modify anything. If you want to have like a tube model, the same thing with some modification. Let's say OK, and you have this element. Let me go to here, display, I don't want to show these nodes because they are annoying. Alright, if I switch to work, you can see we have nodes, elements, material properties, and support. Let's say press support and display. So we have the support in different places, plastic links, and so on and so forth. Let me undisplay this, and load case and moving loads. Alright, so the last thing we're gonna do, going to the same thing which we did with the arch bridge. Going to analysis, moving load analysis control. Going with exact influence line here, because we have shell going with this method. Plate, center, and also stress calculation. When you select this option, stress calculation, so later on you can it can help you to check the equivalent forces from stress values. Alright, say OK and press run. Could save it somewhere. OK, so it's performing the analysis. So here there is a message window. If you have any problem in your model, it's gonna tell you, give you a warning, or give you an error, or you can see the steps that is now performing the analysis. So now I'm going to, because I showed you a lot of features on Arch Bridge, so I'm not gonna go through all the result extraction. So just showing you a couple options which is useful for this type of bridges, and just sticking with this. All right, analysis is finished. It took 63 seconds. Finish the analysis. Now what I'm going to do, right click and go to the forces. Actually going to stresses, plane stress, plate stresses. Alright, and then see for the dead load, for example, we could go with the local axis and average nodal. Are you following me here? Average nodal, we could select for the top and bottom of the slab, and you can select different component for sigma xx, sigma yy, or sigma zz. I'm going with the sigma xx, and then I want the contour, deformed, and legend. Apply. So you can see the deformed shape. So if I go back and say uncheck the deformed shape, say apply. Alright, let me switch to okay. On the deformed shape, if I click the bottom, so I'm getting the different result for the sigma xx, which showing the stresses at the bottom of this slab, and this one shows the stress at the top of the slab. Alright, let me go with the undeformed, and then switching to the top view, you can see the skew of the bridge and the stress contours here. Alright, on the left bottom side there is the option called cutting diagram. So if you press on this one, you have an option to cut across this slab on each direction you like. So point 1, see, we're gonna have point 1 and point 2. When I'm clicking on that, it becomes green. So let's say I'm start from here and wanna have a cut through this element. So simply add it. I have one cut. Let's say having another cut along the beam, along the slab. So I'm selecting this point and this point. Alright, and add it. So now I have two cutting lines, which if I select the cut on the here, if I select this and say apply, I can see the stresses. I can see the stresses along this cutting section. So if I on the top, if I switch it to the normal view, you can see this stuff. So you can put the values. It's useful if you want to check one section. Another thing I'm going to show you is helping you to calculate the equivalent forces from stress values. What is that? Is I'm going to result in local direction force sums. What it does is on the position I can define one surface from here to here and here. Okay, so if I press calculate, it's gonna create a local axis for that section, and also giving me the equivalent forces and moments on that section. You can see them here. So let's call it cut 1. Okay, and add it. So let me have another cut. Let's say from here to here and here. Okay, then press calculate, and we have another one. And then again, you have the results on this box here. And then by pressing add, we're gonna have cut 2. By pressing add, we have 2 cuts. So if I select them, I can simply press this button here, text output, which is creating a text output for me. So I have them in the text format. All right. So this is actually all what I want to cover today. Thanks everybody for attending this webinar. I hope this tutorial was helpful, and please don't hesitate to contact me on my phone or with the email, which will let me show you. It's going to be here. You can see that at the left bottom side. If you face any problem or you wanted like more information, please contact us. You have a good day, and goodbye.
Muted. Unmuted.
Everybody, we are still here, and